Ray with Hiwasssee Products here at Acres 2024, and we are going to have a little compost showdown. Our completely impartial judge, a giant in the world of tiny things, Matt Powers. Could you tell us roughly how you're going to be assessing the different samples that we've got here today?
Well, it's a pleasure to be here. I'm excited to do this demonstration. Thank you for having me. And I'm going to be diluting the samples in water and then taking drops from that dilution and looking at it and letting it speak to me, letting it show what life is there, the condition of the organic matter, as well as the interactions between that life and the distribution. And so I'll be looking for nematodes and fungi because they're largest first. And so I go at a lower magnification so that everything's further away, so I can only see larger things. And so I'll be looking at nematodes, and you can see some larger protozoa, but usually you're just looking at large fungi, large nematodes, and you can see some other things. A lot of more aquatic pond-like kind of things. So if you're closer to bodies of water, you'll see more things that are large. And then microarthropods and arthropods in general, you would see at that magnification. And then I'll go deeper, going from like the 100x to the 400x roughly. And that all depends on all the different bits, but you start with that objective. And so at roughly 400x, you can see the spores, you can ID them, you can see the behavior of bacteria. It's easier to see at 600x the behavior of bacteria, but you can still see it with a nice camera like this is a 4K. And because it's 4K, you're not bound by this screen, this great screen doing the work right here. But you could blow up a 4K into, a 4 foot by 4 foot screen or 4 foot by 10 foot screen. And you could see things at such a detail and clarity that you really can do things at 600x with a large screen that a lot of people don't realize. The amazing thing about this setup is it really allows you to see things with more clarity. And in microscopy, the clarity is your ability to make a more definitive call, and that's everything. So the more confidence you have in your interpretation is the more confidence you have in the recommendation. So this kind of clarity is special. This kind of clarity is really awesome. And so I'll be doing that. I'll be looking at the behavior of the bacteria, looking at the spores, looking at all the things that I now can see in detail. So maybe I saw a Testate amoeba because it was so big at 100x, but now I'm looking at 400x and I can see inside it. So I can see what it's been eating. I'm like, this one's just eating bacteria. Oh, this larger one, is eating a variety of things. I can see the different spore types inside it. And then you can ID the spores, and then you can look at the ubiquity of the spores and understand the diet of that protozoa in situ. And that is literally the cycling of the soil food web in action. And so all these different microbes reference at different trophic levels, and they all release and cycle nutrients. So that's why it's useful, because what'll happen is you'll have a missing microbe, and then you'll have a missing component of a cycle. And so my work is really about completing the cycles, completing the plant, allowing nature to be nature. And we don't get there without seeing it and verifying that these things are actually there and actually happening. And so that's what we're going to be doing today. I'm excited to see, the different composts. And there may be one that, because they're all in alignment, they may be one that is clearly better, but there also could be better in different ways. So you might have one that's more fungal, but has all the components. You might have one that is heavier in predators, and that's good for systems that need that cycling. Systems that lack those higher level predators of the soil food web, you're adding that and you're completing the cycle. So when we think about things from a cyclical perspective, when we think about the way nature is doing it, we really can see the gaps and the holes, and you see them literally, quite literally, using a microscope. And from there, we can take action. You can make a compost that is tailored to fit those gaps. You make a biofertilizer blend. You buy an inoculant that fills in that gap. And that's really what I'm doing. All I'm doing is asking how nature did it, what's most natural here in this context, and what actions can we take to fill in those gaps and complete those cycles of nature. So that's what we're going to be doing today. And as with always, whenever we look at samples, everything's in a progression. And we never want to do just one test. We're going to look at the biology, but because I don't think we're going to do the nitrate test, we're not going to do the phosphate test, salinity, all these other things that are critical for interpretation. I'll do my best, but knowing that we won't be able to test those things, there's still a lot of variables that, this could be super high in nitrates, and while that you don't want to immediately add it to your soil or add it to your plants because it's so high in nitrates, we could just treat it with EM or lactic acid bacteria and turn those nitrates into amino acids. So nothing's bad, nothing's over, nothing's doomed or cursed. You know what I mean? We just have to understand that where we are and then cycle further to where we want to be. So this setup that I have today is mirrored after my own home setup, but it's not my home setup. This is from Simeon from Hiwasssee Products, and it is fabulous. This is a travel kit. It has everything you need. So if you want to have a portable lab, you want to do consultancy, you want to travel to trade shows or conferences with something like this, this is how you do it. So this table collapses into the back, this goes into that case, and it all goes back into a dolly that you can bring anywhere. So this is an incredible setup. Simeon, you did such a great job. I love this setup because it allows you to see things that no other microscope on the market allows you to see at this price point. So, and actually, there's no other microscope that allows you to see these things as safely. Because this is an LED light right here, and that LED light's special. It allows you to see the invisible fungi that matters most to plants, mycorrhizal fungi. It glows. And so it's an incredible, incredible machine, and you can take it anywhere. It has all the components that I rely upon to do the full assessment. From a microscope perspective, I also do nitrate testing, phosphate testing, all those kinds of things too to get a full picture. But for the microscope, this is my setup: the Epi-Fluorescence, the i4 LW Scientific microscope, the BioVid 4K camera. This is so incredibly important. Folks are looking through eyepieces and they're not recording it, so they actually can't verify it with other people and show what they're even looking at. It's all like, take my word for it. They can record it now in 4K. And in 4K, they can blow it up on a giant screen. And so when the ability to see is your ability to make a strong assessment, the ability to make a strong interpretation and strong recommendation, it's everything. So I love this setup. This is my setup. And the fact that Simeon went the extra mile is so incredible. This has the stains I use. This has, you just look at some of these things in here, I looked everywhere. Most folks can't buy the things that are in here. He went the extra mile with his company to get access to things that you just can't go buy on Amazon. The measurements on here are hyper accurate, go down to 0.5 mLs and even smaller. We're talking about
hemicytometer is right here. Your concavity slides.
Yeah, all the slides I use are in here, from the LW Scientific Hemicytometer to well slides to covers, regular slides, all of it. It's all in here. And so your droppers, your cleaners,
test tube
your
holders,
stains, And it even has the ability to store your camera, to store
Other
samples, to
dyes.
store water, all of it's here. So whether you're wanting methylene blue, acridine orange, things that are harder to get, you have a kit here that has it all, that has refills for it all, and there's a place for everything. So this is the best designed portable lab I have ever seen. And I just honored that you guys made this model after my program and protocols. So that's what we're working with today. And Hiwasssee Products has a lot more than this. They have equipment for consultants. They have equipment for people applying amendments, working with compost extraction, vermicompost, all of it. So check out their products. They're doing incredible work. And yeah, let's dive into this.
And the one other thing to point out is the fact that you can put the Epi-Fluorescence on the i4 in the case. So you can stand the Epi-Fluorescence and the microscope in there without taking it apart to prevent dust and other stuff getting into the components. So it's one of the critical parts. And then the camera goes in with the condenser already attached, so there's no dust going in.
And when you're dealing with soil and sometimes dead dirt, dust is everywhere. And so everything you're doing, you're gonna be in an environment where you're serving a farmer. Maybe you're in a farmhouse, maybe you're in a facility, but you're gonna wanna set this up and you're gonna wanna have that clarity. So if you're wanting a portable lab, this is the place to go. All right, cool.
Okay, those are our 3 samples. I got a slide set up.
So something I do that's from the DNA world is I use my pipette to mix things. And so people are shaking things and then settling right there.
So you want to keep it in suspension.
And it's not in suspension.
Yep.
And so you have to, with micro pipettes, you actually have to mix it in order to get a good DNA read throughout the entire process. So that's something I learned from that world that I always do.
Start with that. I'll get the other one ready.
Okay, so already, we didn't move around. I already see fungi. I see, large pieces of sand. I see aggregation. I do see, looks like a section of blue tarp. That's microplastic. I do see a wide range of foods that are organic matter. And then I also see a range of broken down organic matter, ranging from stuff that's more light brown and more fulvic to dark brown, which is more humic.
And this is that 4x magnification.
Yeah, we're not even close.
We're not even
zoomed in
close
yet. But I can just see it from here. So again, we're just going further in. I'm gonna reorient myself because I see something already that I wanna look at. Typically we mow the lawn at the 100x objective and we're just roaming around.
10x.
It's a 10x objective. It's a 100x total magnification. And so we mow the lawn here and we look for nematodes. We look for, and usually we're looking at this magnification for fungi, though we saw it at 40x because it was so big. So I want to see what that is right there, that orb. And so I go down to the 40x objective, which is 400x magnification roughly. So right here we can see beautiful fungi. And then this to me is really dark organic matter. This could be biochar. Is this biochar on here?
It could have a bit. Yep.
Yeah, we found biochar. So it's and then who's next to it?
The Testate.
Testate. That's a Basidius spore.
Yeah.
You can see because one end has a little dimple to it, and then this is a Testate Amoeba, and you can actually see the spores all around fungal spore, and then there's, let me go a little bit lower, fungal spore. And there are also smaller spores, like that one, that are sometimes mold spores, but they're very small, and that becomes, those mold spores are quite often the food that, spore-wise, that these things are eating. And so when we talk about biocontrol, it's actually very pragmatic. And we can see inside this Testate amoeba, if we jump to, you got my, yeah,
That's 60.
Okay, so we can see inside here that there very clearly is a bacteria, organic matter looks like, and I wouldn't definitively say there's spores in there because some of those things don't have that roundness, but it is a Testate amoeba. It is cycling. There are wonderful things all around. So I'm gonna jump back out all the way to 100x magnification. And if I'm gonna evaluate something, I always go to the top left corner.
Lots of fungi as you're going up.
Yeah, I could move slower, I guess. So football-shaped spore right there. It's a giant one. But that's a pretty easily identifiable one too. You'll find that in your spore keys online and in books. So here I am, I'm at the top corner. This is where we mow the lawn. So I go down and up and down and up looking for those larger organisms. Because you can see them from here. But if you're super close in and it feels like you're going forever, right? And you don't need to do that to yourself. So far this has been awesome. And I'm just gonna look for movement because the reality is you can see the hyphae or the fungi, sure, very easily identifiable. Your eye will catch that. But there's only certain things that move that you can see at this magnification. And most of the time you're talking about nematodes. The thing with the way I do things is if you're gonna have enough life, you'll find multiples. You know, if you're at the right level, you'll find multiples, and so you'll be able to see that same type at a different angle, and you'll be like, oh, that's what that was. But it's best to be non-definitive because otherwise you're gonna trick yourself.
You're misrepresenting it.
Yeah. And so, and that's the great thing about this space is you have to have that abundance to really stand strong on your interpretation. So seeing like protozoa is not good. You know what I mean? You should be seeing these things in ubiquity. There's a spore, giant spores right there.
Yeah, cluster of them.
Spore likely right there, but that could be a really dark Testate amoeba. Probably not. Lots of fungi. This is looking beautiful.
You can almost try the Epi-Fluorescence out on this guy and see if it is the veins. Because you do grow cover crops in here, so there could be a little bit of potential mycorrhizal.
That's amazing, yeah.
Where did that chunk go?
It's above.
Oh, there it is.
I just wanted to see this.
There's a
Testate amoeba,
yep.
And you can clearly see spores.
Yep.
And that's what I mean. You don't need to feel like you're stretching. You don't need to feel like you're like reaching for anything. It actually should be obvious to you and redundant. So that my whole thing is you should be doing this until you're like, yeah, we get it. I got it. I know it. And that's your inner sense being like, I'm so sure that I'm now slightly disgusted. Right? So, right? It's like when you eat too many pancakes and you're like, I can't eat anymore. Like your body and your mind will tell you. You mow the lawn, you see those things, and then when you go closer, you start doing analysis of the bacteria and all these things. But it's the redundancy that makes you go, yeah, I know what this is. That's the sign that you actually know it. And so a lot of my work, especially when it comes to like getting beyond counting, to be able to look at these things and immediately know like their condition within a few minutes, it comes from having that experience, putting in those hours, developing your eye, working with groups of people, doing microscopy, so you see dozens of different variations on a theme, and then again, you develop your eye. And our eye, humans, the way we work, the way our eyes develop, we're pattern literacy people. We look for the pattern, and as soon as we have that universal pattern in our minds, this is why quite often I use cartoons or visuals that are simplified to create a universal Platonic ideal in your mind, because then you see it everywhere. The reticular activating system of the mind makes it so that you see the spores suddenly there, and then you see the spores all the way around. And so then you're like, oh, this is eating these spores. And then you look it up and you're like, this is the diet of that thing. So that's a lot of the way I do this is the philosophy and the pragmatism behind it is completely different than other schools of thought. So yeah, I wouldn't be surprised if we saw spores in this. So this is a chunk of wood. You can see the grain in it. And you had wood chips, right? Mm-hmm. Yeah.
And some shaving, right?
So this looks like,
Not quite green, the bright green.
yeah, it looks like there are some things in this, but not. I wouldn't say that definitively that this is being broken down by fungi or is inoculated in any way, especially when you bounce out here and see it, right? You can see some phosphate crystallization there. The thing to realize is that people are like, oh wait, but this is mycorrhizal fungi. We're looking at a saprophytic situation. Did you know that all the saprophytic fungi and all these things are releasing digestive enzymes that solubilize the calcium and phosphate around it? This is why the majority of the calcium and phosphate in plants is theorized to all come from fungi. And so what happens when you solubilize calcium and phosphate is they form a pool, things feed on it, and then it dries back out again. And so it recrystallizes. Well, it often is being pulled out of other compounds and then forms this pure crystal. And those crystals have phosphate in them, and so they're glowing. And so you can see fungal action by looking at those crystals. And they're pulling it out of this organic matter. And you're like, organic matter, plants, okay, what are the macronutrients for plants? Nitrogen, phosphorus, potassium. So of course, in our plants, it will be there. And even if it's diffuse, which is probably what that is, it's more diffuse, right? That's why there is a glow. You know, there's a slight glow.
But it's not the bright green.
But it's not concentrated yet, right? So fungi isn't like pulling it out and isolating it and creating a concentrated crystal form. So a lot of people have no idea that this is possible. And that's why I do what I do, because most people, A, haven't even heard of this, and then B, the only other versions of this that exist are in universities, and they have very like strict ways of using their devices. And so they have you on assignment, and you don't get to play around, explore, and figure things out. That's what you can do with this. So I really value this. So we can take a moment now to just kind of, because I'll speed up my mowing, but I want to look here at the bacteria. What's so great about BioVid, 4K cameras, LW Scientific's clarity of their objectives is that 400x, you can watch the bacteria. We can see bacteria dancing. We can see bacteria interacting with each other, forming these pairs that are most likely doing horizontal gene transfer. That's why they're vibrating against each other. And then some of them, let's see if we can find a pirouette. Those two are pirouetting around each other. You see it, buddy?
Mm-hmm.
Yeah. And bacteria was recently discovered that they have orbit. So they have orbit around themselves. And so when they get caught in each other's orbit, just like in space, when you get these two cosmos reacting and they go like that, like a supernova and all those kinds of things, that's what they're doing with the energies around them. And what's crazy is that orbit contains pieces of DNA that phages are holding. Phages are basically viruses for bacteria and fungi. And they are releasing DNA in conversation, in communication, in reaction to their environment. They're adapting in real time. So we actually can see why horizontal gene transfer is faster than evolution, because these things aren't in milliseconds making new ones. Otherwise it'd be like and fill the screen. But they're exchanging DNA in real time in response to their environment. They're adapting in real time. That's why this is faster, and you can literally see it. So the activity is high. There's lots of movement. There's lots of interaction. This is good, and I've done enough counting. I've done enough isolation with hemocytometers to know this is in the 10 to 24 range of bacteria. So it's solid. But it's also not just bacteria, it's active. And so this is why doing DNA testing is flat. You don't see any behavior. Doing PLFA testing, it's flat. You don't see the actual behavior. So I can show you 2 slides and you'll see one's all active and moving, and then you show the other, same exact count of microbes on PLFA, except one's dead. They're hardly moving. And so they're going into senescence. They've run out of food. And now, because they're the baseline food for everything in the soil food web, you're about to hit a wall. You can see the future. And that's how powerful looking at just this screen is. I'm not counting. I'm not trying to be like, who are you? To the individual little bacteria. You don't need to do any of that. That's all like fallacious. That's people like, thinking, that's people not actually allowing nature to tell them how it is. That's people imposing, abstraction, imposing deconstructionism, imposing like all the stuff that they are taught in college and universities, the way of evaluating things, and it's confusing them. And so so many of our tests are flat. So many of our tests don't take the actual into account. And so I love this because for the first time we can see things. For the first time we can verify things in a way that people haven't realized they could. So this machine's incredible. I'm gonna back out again, and I'm just gonna rush through, and we're gonna go on to the next one. There's tons of fungi. I can just hip shot and tell you that this is fungal. This is super fungal. This is probably 60 to 70%, 60 to 70% fungi in terms of the fungal to bacterial ratio. Especially because when we got down to the bacteria, they have space around each other. If it's anaerobic or like way too bacterial, they'll be forming colonies and clumps around things, and they'll actually be swarming. Huge hyphae. And again, if we shook too hard, none of that would be there. That, sharp-bladed biochar would have chopped it up. So I go shift over a section so I know I'm not repeating. Gorgeous fungi.
Yep.
Connecting the organic matter. But see, we're essentially like in a plane flying over this, looking down. And we could drop down lower and see closer, but the things are so large and obvious that we don't need to.
Yeah.
No, it's a cilia.
Yeah.
Or wait.
I think
No,
it's a flagellate, one too.
Flagellate! So flagellates are good. You don't want too many. So you can see that it's actually at a different height. It's bobbing in and out of the different levels of the slide. So fast. But the way it's bumbling, it's because it has this flagella, which is essentially like a tail or like a whip, like arm. And it allows them to move around, but it's not very efficient. The ciliates, because they have cilia all over them, are much more adept at maneuvering. This is like a unidirectional engine, you know, so they have to like use it for everything, right? And so they have to be like awkwardly go around things to get to the other side. Ciliate can back up, forward, move any direction. And just looking at the bacteria, we have bacilli.
Yep. There's a few rod-shaped ones.
Cocci, bacilli, that's a clear one right there, beautiful. We have actinobacteria, which is bacteria. But it looks like false fungi, you know, so folks often get that confused. We got great spores, lots of good minerals, biochar. Lactobacillus.
Yeah.
So this is Lactobacillus right here. It's a rod. That's a really great thing to see because it's biocontrol. And a lot of times people will be talking about, you know, EM, how they're facultative anaerobes, and oh no, here's one. So, not so controversial. It's beneficial. Actually,
another flagellate.
Yeah, another flagellate's bumbling through. It's moving pretty quick, actually.
Yeah, there.
Yeah, this is great compost. And even though it doesn't have, that we've seen, nematodes, there is cycling happening, and that's the key. You can always add in a predator-rich nematode mix. And you could also buy nematodes that are beneficial. And so you're seeding with the nematodes you know, and then providing with the food that they like. So if you already have nematodes in your system, you'll be adding food
for them to eat.
Yeah. So it's like the nematodes will run through your fungi. Like you'll have nematodes that are fungal feeders that'll destroy all your fungi in your compost. And you'll be like, right? And so it's like everything has a place, everything has a purpose, especially if we just see it as like a part of a cycle. And so one of these other composts might be predator rich. And so you would just combine them. But again, what I've seen is it's like once people establish a mother culture that has everything, it really helps stabilize the consistency of the life. This is why I have drops taken when I do assessments from the lowest, the mid, and the upper, because they're different. And even if you take a sample and there's nothing in it, right next to it there could be a sample with something in it. This is why doing as many tests as possible that you're comfortable with, that you have time for, is necessary. And that's also why it's important to be non-definitive, because again, the variation within the soil is great, and some soils it's greater than others. And so understanding that, grounding yourself in that by doing the reps really helps.
There's your corner. Yeah, it's the Duncan's.
All right, Duncan, here we go. So right off the bat, that looks like a spore, or that's burst, or that's a wide mouth Testate amoeba. Let me actually just dive in on that. Whoa. Okay.
Another big one right below it.
Yeah, I saw that. So I was like distracted. Yeah, so there's a big Testate amoeba right here.
There's your little one.
Yeah, that's a spore. Yeah, that looks like a spore. Interesting. Yeah, because there's no mouth. So there's one right there, and you can clearly see its mouth.
That's the other one we looked at.
You can see the edge around it. It's a very wide mouth. It's not one of those ones where the mouth's on the side. So this is awesome. And just looking at it right off the bat, I see two bacilli that are connected. They're probably exchanging DNA. I see. That's a spore. Spore. Spores are very easy to identify because they're like usually perfectly round, or they're like a football shape, or they're round and have a little bump on one side. Mycota. And those are basidius spores, right? So what's something that I instantly notice about this is it's like hazier. And so that could be humic compounds. So a lot of times when you get like hazier or there's coloration, those are very diffuse, fine particles. And essentially are coloring their dye. And fulvics and humics do that. And so do sugars. Create a haze. All right, so let's go around. So already we see a great variation of organic matter. It looks similar in the aggregation. It looks a little bit like this has larger aggregates and perhaps a little bit more organic matter that's undigested. I see a lot of organic matter pieces that are being digested that are light colored. And there's of course sand all around. Without even going any closer, we can go closer, but it looks like you can see the septa from here.
Yeah, it's a pretty clear one.
Yeah, so this is super cool. There's a little bit, there's definitely less humics. There's less like darker organic matter. You can see how light and yellow everything is here.
Flags.
So this is darker, right? So we've got fungi. It looks like we've got less fungi on this sample. It looks like we've got a little bit less aggregation. We've got good spores. But this sample could be pH 7 and the other one could be pH 8. So when it comes down to that, you know what I mean, you suddenly start changing your mind about what you're going to be working with. But this isn't bad compost in any stretch of the imagination here. You got good spores. You've got great Testate Amoebae. Yeah.
Fungal.
That's fungal. I bet that's fungal. I bet that's fungal. I mean, like I'm seeing, you got plenty.
Yeah, another chunk of flame.
Yeah, you got fungi. It's just not as strongly expressed and large in terms of like branching hyphae. There's a range. I mean, here you see a huge range of aggregation and organic matter. There's a spiralocellulose.
Big Testate maybe.
Yep, there's great expression of Testate Amoeba in this.
That's some nice fungi.
Beautiful fungi. That's probably fungi too. Not as thick. That Amoeba is a spore.
Is this some sort of spore?
I would assume so, yeah.
Looks like it has double walls.
Actually, that might be a Testate Amoeba on its face.
Sushi up. There it is.
Yeah.
Yeah, it is.
So it is a Testate Amoeba with its face stuffed with organic matter. He was hungry. Wow. So this right here
It's right against, yeah.
It's nutrient cycling. You can just see it. And it's going to extract the biology from that. It's awesome. All right, so jumping back out. And just look at in relation how large it is. It's massive.
It's huge, yeah.
So that's
that
really,
10X.
really good. And I mean, we can just see so many things. Fungi, spores, hyphae. A lot of times when you're mowing the lawn, as you travel, you're sometimes pushing down the slide, sometimes it's just uneven, and you just have to reset your... That looks like Diplococcus. When you were mentioning that. Or that looks like a very interesting spore.
Or is that algae?
I mean, well, actually, you want to look? Let's see if it's algae. Not algae.
Okay. Algae will glow. That's right.
Algae will turn red
Yep.
because it's photosynthesizing. Yeah, that. And the reason I say is a spore is because you can see all the elements inside of it.
You can see everything inside, yeah.
It's wild.
That's cool.
I've never seen that one before. That's unique to me, in my experience. It's beautiful. All right, so let's see if we can get through and find some nematodes. Yeah, so this is definitely a better sample for testing amoeba, that's for sure. It's close to the comparability of the other one, but if you notice the difference is the other one was branching. These are segments of fungi. Hopefully you didn't do it too hard.
That's the one you shook up.
Ah, it's my fault.
I did this one and this one.
But I did it gently, so it tells you that they didn't develop the branches because they didn't have enough food or time or stillness to create that.
They're straight up. Really?
That's a big one.
Huge. Yeah, the size of the testing amoeba is an indicator of health. It's amazing.
So yeah, the third compost we are looking at is one of the products we retail. It's out of North Carolina. It's a bamboo biochar based compost, and it has had really good results in the past. So we'll see how it compares.
Okay.
So this is the third sample, and we just put it on and immediately saw a nematode. So I think that bodes well.
Yeah, right there.
And you know what's going to hold still for us? And I can see its mouth parts. It looks like it might be either a bacterial feeder or a predator because its mouth is so big. It's going to hold still for us. Oh, it looks like a Diplogaster. Gasteridea. So yeah, this is featured in my book. It's got a wide open mouth, and if you get really detailed, you can see, well, yeah, you can look at the bulbs too. But if you look here at the mouth parts, you can see these little hairs, these little spikes that stick out, and they help them gather in. They're their whiskers.
Bring
in the bacteria.
Yeah. So that's bacterial feeder.
Yep, and that makes sense when you look around.
Lots of bacteria.
And there looks like, it's vibrant, just like the other samples, but it looks like there's more. A lot more bacteria. So there's more bacteria, there's food at the baseline of the soil food web. We've got, it looks like potentially streptomyces. That's actinobacteria. We got spores. See the basidius spore with the little bump?
Yeah.
Yeah, I mean, once you see the things, you're like, oh, it's the oval shape with the bump. Basidius spore. I mean, it's like you can't not know it, like once you know it. So all this stuff is stuff I teach in my courses. My books showcase all of these microbes. And Oh, look at that. Look at that.
Testate amoeba.
Let's look at this testate amoeba for a second. And let's talk about...
What's it eat?
Oh, those are spores.
Spores inside. Yeah, there's some
So
big
there
spores.
are giant spores. The spores are literally almost the same width as the testate amoeba itself, which shows that these spores are squishy. They're like giant balloons. And so they're sucking them in and they compress and then pop into them. So you can now look for those spores and find them, ID them, and then you know the diet of this. And just looking at the way things are behaving, we have bacteria, and you can see that there's that haze still. Let me just do something here. Yeah, okay. So depending on where you have your condenser open, you'll see things that are either hazier and more natural looking light-wise. The colors here where it's fully closed look much more natural. But when you put it all the way closed, it becomes super, let me turn the light up for you. It becomes super high contrast. The edges on things, the purple ring around everything becomes obvious. So I always want to keep it in that sweet spot in between them. And yeah, it is hazy because there's humics in here at a high level. So
nice fungal.
Yeah, it's beautiful fungi. Yeah, this is beautiful.
Tons of testate amoebas in here.
This is already, we're like a minute into this one. So the third sample is the winner. We have more cycling, we have more diversity of aggregation. There's more aggregates, large, small, rich, brown. There's so much fungi. This is just obvious. And that's what happens when you put things next to each other, when you do side-by-side comparisons. And this is why I'm creating a database, the Our Soil database. So literally practitioners can hold up a bad sample and a good sample and see where they are. Because our ability to compare, the human modality of our eye and the pattern literacy, there's nothing like it. And it's so powerful. Some people are like, oh, I know that's the right one. And it's because they build up their pattern literacy. They've developed their fluency. And it also is pretty obvious when it looks this good. You can see spore, like look at the spore, look at the spore. They're huge spores. Spore there. Yeah.
Tons of testate amoebas.
Just tons. Yeah, and look at that, yeah. The diversity of spores on this is wild. And we're not even moving around very far. So let's,
it's a tardigrade.
Yeah, it might be a pinworm. Yeah, because it doesn't have that.
It doesn't have the feet on it.
Yeah. So this looks like a type of pinworm. We can see that it is eating organic matter, pulling it into itself, squishing it, and digesting.
You see all the little digestion here. See?
Amazing. And I've not seen that variety of pinworm before.
Receptor.
Beautiful. Actually, you know what? To verify this, I'm just going to do something. Here we go. Let me cover that up for a second. Yeah, it is. It's an Epi-Triad. It's a pinworm. So one of the things I discovered with this device is that Epi-Triads that are feeding on fungal dominant compost embody the actual phosphorescence of what they're eating. And so their hairs autofluoresce when they have a fungal diet. And so this is something I discovered, and I have not been able to find anyone else to ever talking about this in any of the literature. And I think it's because no one is looking at compost with this device. And really so this is the first time we really can see how unbelievably beautiful these things really are. Yeah. And because these things autofluoresce because this is a natural bandwidth of light. It actually is, but it's a slice of the light, and so we get to see this so clearly. Do you know that some microbes can see in different bandwidths, and so they actually are probably seeing the glow and are attracted to the glow and going to that to feed on it.
That's cool.
So, man, you can just see the digestion so fine.
That's fascinating.
Are you glad we did the third sample?
That's why we do the third sample.
That's why we do the third sample. I'm blessed. I love it.
That's why we sell this sample. That's the stuff we retail.
Yeah. So this is Hiwassee's own product. So guys.
It's not our product, but we resell it.
Yes, it was available
bulk,
through Hiwasssee Products. I love it. And you can see fungi there. Just so much. Oh my gosh. This might be the most fungal compost I've ever seen. I'd have to.
That's good to hear.
I'd have to microbiometer it, but this is definitely in the 70s, and it could be higher. And then the thing to think about is when you're doing fungal to bacterial ratios, what if you have more bacteria and also more fungi?
It's the same ratio. It's just
the same ratio, but that's why you need the biomass. So all these tests work together for our comprehension. This is why I teach holistic testing in regenerative soil and regenerative soil microscopy. Oh my gosh, I'm so glad we filmed this. And as we noticed that nematode had stilled, if you don't go quick enough, they often can still, and then you have to look for the pattern of them rather than their movement, and that's a little bit harder.
There's another one. Holy cow.
Yeah. Yep. And when
What is
people
that
talk
thing?
about, it's another one.
Is that the same
It's a
one?
pinworm. When they talk about, no, it's a bigger one. When they talk about cycling of nutrients and, microtillage, this is it. Yeah, there you go.
There's the glow, yeah. That's cool.
So I basically stumbled upon a way to identify echitriad fungal feeder worms in my work with this device. And no one had ever seen it before, so for a long time I've just been pointing this out and trying to get people excited about it. And yeah, it's just so much fun. I love my work. I teach regenerative soil and regenerative soil microscopy. I've got books, I've got courses. You can go to regenerativesoilscience.com, check out all this. I can teach you how to use this. This is unparalleled. It allows you to evaluate things at such a depth, such a level that you can differentiate between composts, between soils. You can know good, better, best. You can know how to improve. You can see the missing links. You can see how to complete cycles. And you can see how all these things come together in this space. I say that, the microscope is the context for the actual context for all of our tests to find their interpretation. If you do just a nitrate test and don't have anything here, you really don't have an understanding of what your soil can do. You do just biology, that's good, but unless you do that nitrate test and that pH test, you don't even know where you are. And so all these things work together. This is such a critical component, and this is really the capstone component in soil science for soil interpretation and soil remediation and evaluation. So it was just so fun to be with you today.
That was a lot of fun.
To evaluate these, to declare that the third one is the winner, but
Let's go.
absolutely obvious winner. And thank you.
Yeah, who's the runner-up?
The runner-up would be the first one.
The first one. All right.
There.